All right, let's take a look at it. So we got the cube root of 130. This is problem number 3. I'll go to the whiteboard, or blackboard. Okay, so let me write the cube root of 130. Question is, what is it between? And it's not difficult to do. These are not really big numbers, so it's kind of easy to look at. I can say that it's between the cube root of 5, which is the cube root of 125, and I'm sorry, that's 5 cubed. Sorry about that. And the cube root of 6 cubed. All right, let me write that down for you. So it's the cube root of 125, which is 5, and the cube root of 130 is above that, certainly, and the cube root of 6 cubed, that's going to be 6. That's 36 times 6, right? So that's going to be 36 and 180, and you're going to get 216. All right? So I could write the cube root. By the way, I know the cube root of 130 is 5 point something. All right? Now, I just want to go through this to make sure you understand what we're looking to get. So I'm going to say the cube root of 130. You could write it down as the cube root of 125 plus 5. You could do that. And you could also write it down as a cube root of 216 minus, well, let's see. And that would have to be what? So it's going to be 70, 86. All right? So let's just take a look at it. And I think you know what I'm looking for. I'm looking to factor out now on this one. Let's see, 125. That would give me 1. I'm going to get the binomial form, by the way, plus 5 over 125. All right? Before I go forward, I want to check this out. And 216 minus 86, that would be 0. And let's see, you get, 130. That looks okay. All right? So 130. Let's write this down. It could also be written as a cube root. I'm going to factor out 216. That would be 1 minus 86 over 216. And both are good. They really are. They're both good. So let's write this over here. Cube root of 125 is 5. Cube root of 1 plus, 5 over 125, you want to simplify it, it would be 1, and that would give you 25, right? And this one over here, the cube root, the cube root of 216 is 6. Cube root of 1 minus, you know what, that number there, I want to point this out to you. You know, they have to be proper fractions for this to work. And the question is, are they proper fractions? Of course they are. But which one's the smallest one? This one here. So this is going to converge faster than this over here. So this is the one you want to use. All right? Now, then the big question comes is, how are you going to do that? By expanding. All right? So by the way, you could expand this one here, but it's going to take more terms. It does converge, by the way. But you're going to need a lot more terms. I mean, I shouldn't say a lot more. You're going to need more terms for it to get converged to the same level of accuracy. So let's write this down then. And so the cube root of 130 is going to be equal to 5. And now you do the binomial expansion. And the binomial expansion you're doing on is this over here. 1 plus 1/25 to the 1/3 power, which it's pretty easy to write down. But again, I would say have these expansions written in front of you. So I'm not looking for you to do any computations, by the way. I'm just looking for you to write it down now. So 1/3, this would be 1 over 25. The next would be minus 1/9, I'm sorry. And then it would be 1/25 squared plus 5 over 81 over 1 over 25 cubed. And this really does go on forever and ever and ever. 10 over 243. And it would be 1 over 25 to the 4th power. Plus yada, 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 yada. It goes on forever. All right? Now, of course, what I'd like you to do is on your calculator, take the cube root of 130, and you get a decimal number there. And your calc is pretty good. I mean, your calc could probably give like, 9 or 10 places easily. If you're using Sage, you get as many places you like. And the deal about this one over here is, I'd also, you get an approximation over here. What do you mean with that? You approximate this, and it's going to be on a calculator 5.06, yada, yada, yada. I'm not sure off the top of my head what it is, but something like that, all right? And then if you do this over here, what I'm saying you should do is do the calculation on your calculator. And, after you do, one calculation, do another one, another one, another one, and you're going to start to see that it gets close quick, all right? It gets close quick. And so I would say do it, both sides. Do this on your calculator and do this on your calculator. And you're going to see remarkably similar. Now, granted, there'll be some place where they're going to differ, and that means you got to take more terms. And that's what we're trying to get you to, get more and more terms. What's the problem with taking more and more terms? It's difficult, the computation, all right? So what's the deal over here? Again, I think this one was kind of obvious which one to use. It's the one closer to 130, which is certainly the 125. The 216 was almost ridiculous to go there. But I'll be honest with you, it would still work. You could still do it, all right? It would still work. Why is that? They're both proper fractions. And for this to be convergent, the number here, 1 minus x, 1 plus x, the x has to be a proper fraction. In both cases are proper fractions, and you can certainly do that. Again, I'm not doing what Wells does. They must have had a really tough time computing these guys over here. But they were much better at arithmetic. They really were. There's no doubt about it. And the fact they didn't have a digital computer around, they had to be good at it, or they wouldn't go in that field. All right? Thank you.